Hi, my name is Nirja,
And I'm Katie.
and this is our data science final project on exploring student diversity at U.S. higher education institutions. We started by looking at a data set of U.S. institutions and their enrollment demographics. We looked at a variety of variables, including institution, enrollment, women, and many different racial groups. Our main objective was to answer four questions centered around diversity, clustering institutions, and predictors of enrollment. The first question we aimed to answer was which variables have the strongest predictive power in estimating the proportion of minority students at an institution. We started by creating a new variable, minority proportion, defined as the number of students from minority backgrounds divided by the total enrollment in an institution. To determine which predictors most influence this proportion, we used lasso regression. Next, we split the data into training and testing sets. And then to visualize the influence of each predictor, we created a bar chart, as seen on the left, of the absolute lasso coefficients. In this bar chart, Black and Hispanic student populations were at the top of the predictors. Black students had a coefficient of 0.13, while Hispanic students had a coefficient of 0.09. White students had a negative coefficient of negative 0.125, which suggested that institutions with higher numbers of white students tend to have lower minority populations. Then, based on the bar chart, we selected the most important predictors and plotted them against the plotted minority proportion to help visualize the relationships between these features and the outcome. The the plots for Black and white populations showed clear positive and negative trends, respectively, in relation to minority populations. Although the Hispanic population emerged as a top predictor in the Lasso model, its scatter plot was less or more inclusive, suggesting that its influence may be more complex or context dependent. The second question we aimed to answer was, can clustering identify institutions with similar gender balances and minority compositions potentially useful for recommendations? To answer this question, each racial group's raw count was normalized by the total enrollment at each institution to produce proportional features, ensuring fair comparisons across institutions of different sizes. To determine the optimal number of clusters, we generated an elbow plot by calculating the sum of squared errors, or SSE, across a range of clusters from k equals 2 to 14. Based on this metric, we determined that k equals 6 was the optimal number of clusters. Then these six clusters, as seen on the left, were seen to capture meaningful differences in racial and ethnic representation among institutions. For instance, Cluster 0 is characterized by a high proportion of Hispanic students, making up over 50% of the population, alongside moderate representation of white and Black students. Cluster 1 is dominated by Black students, or 55%, aligning closely what with what one might expect from historically Black colleges and universities, or HBCUs. Next, to visualize clustering results in two dimensions, we use principal component analysis, or PCA, to reduce the seven demographic features to two principal components. Institutions were plotted in this reduced space and color-coded by cluster assignment, enabling a clear view of the distinct groupings formed by the model. The PCA scatterplot, which projects institutions onto the first two principal components, revealed well-defined separation between clusters. This confirms that the demographic differences captured by the clustering algorithm translate into distinct underlying structures in the data. The visual separation observed in the PCA plot adds robustness to the clustering results, as well as indicate that institutions within the same cluster share similar demographic profiles.
I think question three, how accurately can we predict an institution's total enrollment size using demographic composition data, and which variables are most important in making these predictions? Firstly, we started off with a scatter plot, and we wanted to test the true total enrollment of each institution against what the random forest model predicted. Points do lie close to the 45-degree diagonal red line, which means that the scatter plot did show that most of the data on the demographic side aligns very well with the fact that it is predicting which institution they will go to and its effectiveness. The model does fit well. The scatter is tight and it does have some spread though, meaning that the prediction on accuracy is not always high per institution. The points are relatively close though, and it indicates that there's a moderate to good prediction accuracy. However, some spread is visible, which means that at higher enrollment values, there might be some larger errors and margins that we need to account for. Later on, we also did the bar chart that ranks demographic variables by their importance score in the random forest model. The importance reflects how much each feature contributes to the reducing prediction error, revealing which demographic groups are the strongest predictors of enrollment size in this data set. The biggest predictors in enrollment size are American Indian and Alaskan Natives, as well as Native Americans and Pacific Islanders. These features strongly influence the enrollment size at the institution. Foreign residents, Hispanics, whites, and women have the smallest demographics that influence enrollment size when predicting. This helps identify key demographic drivers and the specific groups that have the strongest influence in determining the predicted enrollment size. Institutions with larger proportions of the top ranked groups likely experience more consistent or distinctive enrollment patterns, and it is more commonly larger groups like white and Hispanics that are less influential. And this could be because of the variation that it has across institutions. And then lastly, for this questions, we did the residuals of random forest versus decision tree based models. Residuals are the difference between actual and predicted enrollments. Plotting residuals side by side for random forest and decision tree models shows how errors vary between the two. The graph shows that there are smaller residuals, which indicate better prediction accuracy. The random forest residuals are smaller and less spread out than those of the single decision tree. This could be due to the variance reduction. This comparison emphasizes the improved robustness and generalization gained. And the decision trees overestimate. The decision trees overestimate low values and underestimate high values more than random forests. This supports that random forest provides a more robust and accurate prediction, especially across varying institutional sizes. The top demographic predictors are still American Indians, Alaskan Natives, Native Hawaiians, and Pacific Islanders, as well as Asians. These variables exhibit the strongest relationship with enrollment size because of the fact that they are correlated to the institutional type of geographic and cultural context. Our last question is which demographic groups are most influential in predicting an institution's total enrollment size? For this, we did PCA graphs. This graph visually reveals natural groupings of institutions by demographics. If some clusters dominate areas of the plot that correlate with known enrollment sizes, that cluster's demographic profile may be more influential. So high average enrollment and high proportions of Hispanics and women are seen here on this graph. The clustering indicates the institution's group characteristics of their demographic size. And if these clusters were derived using enrollment size of features strongly correlated with it, then the variables contributing most to PCA components may also differ by likely being influenced by the predictors of total enrollment size. And then lastly, we did another PCA projection of clusters. And this shows that clusters located far from others may represent unique or extreme demographic compositions, as in the demographic percentages of race and of gender. And if these clusters are associated with significantly higher or lower enrollment, it suggests that these specific demographics are more predictive of total enrollment. The low average enrollment and high proportion of Native Americans and small overall enrollment base shows a dense spread of points, and it lacks grouping information to draw conclusions, clear conclusions. However, the shape and dispersion still reflects variation in the underlying features used and hints at demographics varying across most institutions. Overall, these PCA-based graphs don't directly tell us which demographic predicts enrollment, but they help us visualize how institutions group based on demographics. which in turn allows us to infer which demographic profiles are commonly associated with higher or lower total enrollment sizes. The conclusion. So, do you want me?
Okay.
Okay, the conclusion. The project overview explored how demographic variables shaped the US higher education institutions and addressed four research questions using lasso regression, clustering, and random forest modeling. The lasso regression found that Blacks and Hispanics percentages are stronger predictors of overall minority representation, and higher white student proportions correlate with lower minority representation. The K-means clustering and PCA that we did shows that institutions cluster naturally based on demographic profiles, and that clusters align with known institutional types and are validated by PCA separation. This suggests potential for policy benchmarking and recommendation systems. Enrollment predictions in random forest show that demographics can reasonably predict total enrollment. Random forest outperforms decision trees by reducing residual error and managing size variability. Smaller groups are unexpectedly strong predictors because of their demographic size and minority status. And the key takeaways are that demographic data is valuable for modeling diversity, institutional behavior, and strategic planning. Findings offer actionable insights for policymakers and administrators focused on equity and performance in higher education.
Thank you.
Thanks for listening.